6 feet beneath the frozen surface of your yard, right now, in January, the ground is sitting at 55 degrees, not warming, not cooling, not responding to the blizzard above it, just sitting there, dark and massive and indifferent, holding that temperature the way it has held it for every winter in recorded human history. And here's the number that changes everything. Your furnace is burning fuel to heat air from -10 degrees up to 70, fighting a 65-degree thermal gap with combustion and money, while the earth beneath your foundation has already done half that work for free and is waiting silently for anyone to notice. The pipe that could capture that thermal gift costs less than a single month of your heating bill. The trench that would bury it costs less than one furnace service call. The physics that makes it work has not changed in 3,000 years. Every replacement cycle, every service contract, every emergency call on a February night when the heat exchanger cracks, all of it exists inside a gap that the earth already closed before your house was built. You were never told that. You were never supposed to be told that. To understand how this disappeared, you have to go back to the Romans, and a principle they understood before the word furnace existed. The Roman hypocaust was not a luxury. It was engineering at its most honest. Beneath the stone floors of bathhouses and villas across the empire, Roman builders raised the floor on short clay columns roughly 2 feet off the subgrade, creating a continuous cavity through which heated air traveled from a central furnace outward beneath the entire surface. The floor above became a radiant panel. The earth below stayed thermally stable. What makes this truly remarkable is not the heated hypocaust itself, but what Roman builders understood instinctively beneath it. The ground was not an obstacle, it was a partner. Archaeological records and Vitruvius's De Architectura both describe Roman construction methods that worked with thermal mass rather than against it, building into hillsides, using earth berms, channeling air through buried clay conduits to precondition ventilation before it entered occupied space. The soldiers stationed in northern European provinces lived in structures designed to use the ground's thermal inertia as a first line of thermal defense, not combustion. The principle predates every gas company, every utility conglomerate, every HVAC trade association by nearly 2,000 years. They had no furnace, they had the earth, and it was enough. Here is the physics, stated plainly, because it deserves to be stated plainly. Below approximately 6 feet of depth across the continental United States, the ground temperature remains within roughly 2 degrees of the annual average surface temperature at that location year-round. In most of the American Midwest and Northeast, that number sits between 50 and 58 degrees. The ASHRAE Fundamentals Handbook documents this. USDA soil temperature maps confirm it across every climate zone in the country. The mechanism is thermal lag. The enormous mass of the earth absorbs summer heat slowly and releases it slowly through winter, smoothing the violent seasonal swings above into a flat, stable thermal reservoir below. Pull outside air in January through 100 feet of buried pipe at that depth, and it arrives at your intake not at -10 degrees, but somewhere approaching 45 degrees. You have just done more than half the work of your furnace using nothing but a tube and gravity. No combustion, no electricity, no moving parts. The physics never filed for bankruptcy. It never got acquired. It just kept working, 6 feet below everything you own. But then something happened, and this is where the first twist lands, because the Romans were not alone. Across the Persian Empire, builders were constructing wind catchers, tall towers that captured prevailing wind at elevation and directed it down through underground channels before releasing it into the building interior below. The underground passage was the point. The air lost heat to the cool earth on the way in during summer and gained heat from the same earth on the way in during winter. Archaeological records of Persian Qanat systems and wind tower thermal channels document buried clay conduits 12 to 18 inches in diameter, sloped slightly for drainage, with intake at the surface and exhaust into the inhabited space below. Medieval European monasteries built root cellar ventilation systems using buried stone channels that maintained interior air quality and thermal comfort through winters that would have been otherwise unbearable. 3 civilizations, 3 independent engineering traditions, 1 principle. Air drawn through the earth arrives already tempered. It is embarrassingly simple. A child can understand it. An industry cannot profit from it. It worked for 3,000 years, until someone needed you to pay a monthly bill. In pre-industrial America, this knowledge was not exotic, it was structural. Root cellars dug 8 to 10 feet into the earth maintained temperatures between 45 and 55 degrees through both the coldest winters and hottest summers without any mechanical input. Colonial agricultural records described them as standard construction, not a luxury of the wealthy, but a functional requirement of any serious homestead. Earth-bermed structures built into hillsides across northern Europe used the surrounding soil as their primary thermal buffer. Documents from the period describe passive ventilation via buried stone and clay channels as common builder knowledge passed through apprenticeship rather than written curriculum. Farmers in Pennsylvania and Ohio built their root structures into north-facing slopes instinctively, orienting intake and exhaust to maximize natural airflow through thermally stable ground. This was the baseline, the default, the assumption every builder carried. Then the pipeline came to town. Natural gas infrastructure expanded across American cities and suburbs after the Civil War and accelerated through the post-war period with staggering speed. The gas line arrived at the street. The utility company offered the connection. The furnace manufacturer provided the equipment. The builder installed what the inspector expected. And in a single generation, knowledge that had been encoded in construction practice for 3 millennia was economically bypassed, not disproven, not replaced by something better, simply rendered inconvenient compared to paying a monthly bill. This is where the system deserves to be described in physical detail, because the system itself is alive in a way that the furnace is not. A modern earth tube, the direct descendant of the Roman clay conduit and the Persian wind channel, is built from HDPE corrugated pipe, typically 8 to 12 inches in diameter, buried 6 to 8 feet below grade in a trench that runs 100 to 200 feet from the intake point to the building. The pipe is sloped 1 to 2% along its entire run so that condensate, moisture that forms when warm, humid air meets the cool pipe wall, drains by gravity toward a collection pit rather than pooling. At the surface intake, an insect screen and a simple activated carbon filter block particulate, pests, and airborne contaminants. At the building end, the conditioned air enters the mechanical room or ventilation system, already pre-tempered, already stripped of its most extreme thermal load. The system runs at 50 to 200 cubic feet per minute of airflow depending on building size and ventilation demand. It makes no mechanical sound. There is no compressor cycling on in the night, no burner igniting, no refrigerant under pressure, no serviceman with a diagnostic kit. The Passive House Institute in Darmstadt has documented earth tube systems preconditioning incoming air by 15 to 30 degrees Fahrenheit in monitored European installations tracked across multiple heating seasons. The pipe breathes, the earth absorbs, the air arrives conditioned, no burner, no compressor, no serviceman, just a pipe and the patience of the earth. The American furnace industry understood none of this as a threat because it never had to. After the Second World War, suburban expansion created an almost unlimited market for forced air heating systems, and the industry shaped its world accordingly. The average American furnace lasts 15 to 20 years. Replacement installed cost ranges from $3,000 to $12,000 depending on system size and regional labor rates. According to Department of Energy residential energy consumption surveys, tens of millions of American households are on this replacement cycle, generating a multi-billion-dollar replacement market that recurs with quiet, clockwork regularity. Every 15 years, like clockwork, they came to your door with a new one. The trade associations that represent HVAC manufacturers and contractors have been among the most consistent voices in building code development processes for decades. They fund training programs. They sponsor continuing education for inspectors and builders. They sit on standards committees where the definitions of acceptable installation are written. None of this is sinister in isolation. All of it collectively produced a world in which the alternative to combustion heating was never placed on the table as a serious residential option. Then the code arrived, and the invisibility became official. By the 1970s and 1980s, the International Residential Code and its predecessors were codifying what American builders could and could not legally install. Earth tube systems were not listed. They had no designated chapter, no approved installation pathway, no standardized inspection checklist. A builder who wanted to install one faced a simple problem. The local inspector had no checkbox for it, which in many jurisdictions meant automatic denial regardless of engineering merit. EPA radon mitigation guidelines, responding to the legitimate concern that drawing air through soil could introduce radon into living spaces, were cited as grounds for discouraging earth contact ventilation without distinguishing between unfiltered direct soil contact and properly designed sealed pipe systems with radon testing and activated carbon filtration at intake. The concern about radon was real and valid. The policy response that treated all buried pipe ventilation as equivalent was not proportionate. It wasn't outlawed, it was simply made invisible. And invisibility in the construction industry is permanent. Here is where the second twist arrives, and it is the one that should make you sit down. The disappearance of passive earth exchange from American construction was not a conspiracy. No memo was written ordering its removal. No engineer was silenced. No technology was suppressed in a back room by a cabal of utility executives. What happened was structural, and structural outcomes are often more durable than conspiracies precisely because they require no maintenance and leave no fingerprints. Expensive active systems, furnaces, heat pumps, central air conditioning dominated research and development funding because they could be manufactured, sold, serviced, warranted, and replaced. Passive systems had no service contract revenue, no replacement cycle, no consumable parts, no software update, no certified technician requirement. They offered no recurring income stream to any sector of the construction economy. And so, when trade schools developed HVAC curriculum, they taught refrigerant systems, combustion theory, and forced air distribution. When Department of Energy research budgets were allocated, active efficiency improvements received the engineering grants. When building codes were written, the systems with industry advocates sitting at the table got the chapters. Passive earth exchange had no industry advocate because no industry made money from it. The awareness gap is not the result of malice. It is the structural outcome of incentive. No one buried the truth. The industry just kept the light off the room where it lived. Individual builders began rediscovering the principle anyway, beginning in the 2000s, through the net zero and owner-builder movements that grew outside the institutional construction economy entirely. Without trade school instruction, without manufacturer support, without a certification pathway, they arrived at the same conclusions the Romans had reached through direct experimentation. Draw air through buried pipe, measure the temperature at the outlet, document the result, share the data. DIY earth tube installations built with materials costing between $500 and $3,000 began generating documented performance data in owner-builder communities, forums, and regional homesteading networks. Fine Home Building and similar publications began carrying accounts of monitored systems with before and after temperature measurements attached. University extension services in several states began publishing installation guides, carefully framed as experimental or site-specific, describing pipe sizing, burial depth, drainage slope, radon testing protocols, and seasonal performance expectations based on measured results from real buildings. The knowledge was reconstructing itself from the ground up, distributed and peer-to-peer, invisible to industry and code bodies. The internet did what the trade schools refused to, but the institutional response was not silence. It was friction. In the 2000s, as interest in passive systems grew among owner-builders and net zero architects, homeowners who attempted to formally permit earth tube installations encountered a bureaucratic wall that was not hostile so much as structurally indifferent, which amounts to the same outcome. Permit offices had no application category for passive earth ventilation. Insurance underwriters declined to cover systems without a listed manufacturer's brand name on the equipment specification sheet. FHA energy efficient mortgage programs and the Energy Star qualified products lists. The financial incentive structures specifically designed to reward efficient construction choices listed only manufactured, rated, certified mechanical equipment. A ground source heat pump with a brand name and a published efficiency rating qualified for mortgage incentives and tax credits. A buried HDPE pipe that achieved the same thermal preconditioning function at 1/20th the installed cost and with zero mechanical failure modes did not appear on any list and qualified for nothing. The system that cost less, required no electricity to operate, contained no moving parts, and had documented performance data spanning decades was financially penalized at every institutional touchpoint relative to the certified mechanical alternative. The physics passed every test. The paperwork failed every time. This is where the third twist lands, and it is the one they cannot explain away because it exists in published engineering documents available to any building official who chooses to look. While the United States was constructing this bureaucratic wall of non-recognition, Germany, Switzerland, Austria, and Denmark were doing something measurably different. The Passive House Institute in Darmstadt, one of the most rigorous independent building performance certification bodies in the world, developed detailed peer-reviewed engineering standards for what they called the Erdwärmetauscher, the Earth Heat Exchanger. HDPE pipe at DN 200 diameter, buried between 5 and 6.5 feet below grade, running 100 to 160 feet from intake to building, sloped precisely for condensate drainage, preheating incoming winter air from 14 degrees Fahrenheit at the surface to approximately 45 degrees Fahrenheit at the building intake in monitored installations across hundreds of certified buildings, tracked over more than a decade of continuous operation. Radon safety in these systems was addressed through EN 13141, the European ventilation standard, using sealed pipe joints, appropriate material selection, and mandatory radon testing protocols. Not blanket prohibition. Swiss Minergie certified buildings incorporated earth tubes as a standard passive conditioning element in the base specification. Hospitals in Germany use them in occupied clinical spaces. Schools use them in classrooms where children spent full days. Municipal housing blocks in Austria incorporated them into new construction not as experimental upgrades, but as baseline infrastructure written into the project brief from day one. Danish energy agencies published multi-year performance comparisons between earth tube preconditioning and conventional forced air heating, showing consistent measurable reductions in furnace load across all monitored sites. The performance database is publicly available in English. The monitoring data is not theoretical or projected. It is measured, time-stamped, audited, and published in engineering documents that any American architect, building official, or code committee member could read tomorrow morning. The Germans measured it, the Swiss certified it, the Americans never heard about it. So here is what reclaiming this looks like. Stated plainly, for any property with 100 feet of open land between the intake point and the building foundation, a backhoe rental costs between $500 and $1,500 depending on region and operator availability. 100 to 150 feet of 8-inch HDPE corrugated pipe costs $200 to $600 at current regional materials pricing. A condensate collection pit is a perforated bucket set in drainage gravel at the low point of the pipe run, installed in an afternoon. An insect screen at the surface intake is hardware store hardware, replaced annually. A radon test kit costs $15 and takes 48 hours to read. Total materials cost for a functional, properly sloped, filtered, and tested earth tube system on most rural and suburban properties, under $3,000. Compare this to the minimum replacement cost of the furnace it reduces load on, which begins at $3,000 installed and climbs steeply from there, with another replacement due in 15 years, and the one after that, and the one after that. Each one arriving at your door like clockwork, like it was always inevitable, like there was never any other option. There was always another option. The trench is dug once. The pipe does not wear. There is no service interval. There is no ignition sequence that fails at midnight in February. The earth does not care what your building code says. It is 55 degrees down there whether you use it or not. Beneath your feet, right now, the temperature has not moved. Not in this winter, not in the last 100 winters, not in the 3,000 years since a Roman engineer first understood that the ground was not the enemy of comfort, but its silent, permanent supplier. The Persian builder who sloped a clay channel beneath a desert courtyard understood it. The medieval monk who cut a stone ventilation passage into the hillside below the monastery understood it. The German building physicist who published monitored Erdwärmetauscher performance data across hundreds of certified buildings understood it. The physics did not change when the gas main arrived at the street. It did not change when the International Residential Code was written without a chapter for passive systems. It did not change when the permit office drew a line through the application and the insurance underwriter declined to list the equipment. 6 feet down, right now, the Earth is holding 55 degrees with the total indifference of geological time, doing its thermal work without a service contract, without a replacement cycle, without a monthly bill, without a brand name stenciled on the side of the unit, without anyone's permission, and without any awareness of the industry that spent decades making sure you never thought to ask. The system is already there. It was always there. It never stopped working. The only thing that ever changed was whether anyone was paying attention.